Okay, we'll finish this session with a problem. We have the properties. I already explained in the table what sections we'd be working with. This is 5.4, so it's going to be a beam with bending. Okay, I'm going to go back to where we started from, back in chapter 3. Okay, there was the equation. That was the equation you've seen before. We've used it before. It was on the test, actually, everything else. So I'm going to rework this equation. If you looked at the videos like I asked you to, and you looked in the book, especially right now on page 204, but back in chapter 3 it was there also. They had this equation also equal to this. Okay? The I over C is actually the section modulus. It's in the table. It's in the table on page 676, 677. Okay? If you look at those members, it's got I and it's got an S. S is a section modulus. So if you take a look at this equation, I'm going to rework it. To maximize it, the biggest possible value you can have for little FB is big FB. So I'm going to take big FB, put it by itself, and that has to be greater than or equal to MC over I, which is also M over S. Okay, this table. We're going to size the member. Okay, this is the only unit in this chapter that requires us to size something. The other ones we're checking something. But this is finding what member we think we want to use. So this is sizing. So I want to pick it out of a table. And to do that, I need a value to pick it. And section modulus is that numerical value. So I'm going to take this. I'm going to move the S over here. I'm going to move the FB over there. So the section modulus has to be equal to or greater than the moment divided by the allowable bending stress. And in your book, if you're on page 204, you can see the equality. I have an inequality. I think this is more appropriate. As long as the section modulus is bigger than this number, we're good. Okay, one thing I want you to do when we do this, inches cubed, pounds per square inch, foot pounds. Okay, so if your moment is in foot pounds, I need you to take this and multiply it by 12 inches per foot to turn it to inch pounds. A very, very, very common mistake on tests. Very common. So I would just change the equation so I don't make the mistake. So I got to find a moment. Where do I get the moment? Where do you always get the moment? Shear and moment diagram or page 114. That's where you get the moment. FB, where do you get it? Where do you adjust it? So you're going to get the bending stress out of the table 5.1, and then you're going to adjust it. And you can see all you need is to get it out of table 5.1. There's the adjustment for table 5.2. There's the adjustment for table 5.8. So if you can get the right number out of the table, you aren't going to have to worry about adjusting it yourself. You just put the value into the table. The table will take care of the adjustment. Okay? So this table is going to do the work for you if you use it right. If you don't use it right, you probably got a problem. Okay, so there's our equation. This is what we need. My equation is a section modulus has to be greater than or equal to M times 12 inches per foot divided by FB. So we get M by either drawing a shear and moment diagram or using page 114. We get FB by going into the table 5.1 and putting it into the formula. So let's do one. While you guys are doing 5.4b, I'm going to do 5.4a. So let's go to the page. The equation that you need is on page 204, of course. So let's go to 5.4a says I've got number one grade. Number one, Doug for Larch. Why is that important? I got to use it to get the right value out of the table. A series of floor beams that are 6 foot on center. So I got these beams that are placed at 6 foot. There's the beam. These are the beams. Okay, 6 foot on center. They span 14 feet. Span 14 feet. If the total uniformly distributed load on each beam, including the weight of the beam, is 3,200 pounds, select the section with the least cross-sectional area based on bending. So in your world, what is 3,200 pounds? Hopefully it's big W. So if I drew my little picture right, I got something that looks like this. That's looking at that beam this way. Sitting on a wall, sitting on a column, sitting on a girder, wherever it's sitting on each end. And then it's going to span 14 feet, and it's got 3,200 pounds on it. So that's the equation. I need the moment. How do I find it? What's the moment of this little sucker? Hopefully by now you realize that's a picture on page 114. And if you look at it, it says big W L over 8. $400, that looks like to be $5,600 to me. There's my moment. I'll put him in there. He goes right here. How do I get the value for the FB? Well, here's a little problem we've got. You notice I put this double line. Now this table is in Canvas in files for you. It's got, I believe, design a wood beam or wood beam design or something like that. Okay, notice that double line. It busts the table in half. The top half is 2 to 4 inches. The bottom half is greater than or equal to 5. Okay? So, if the stresses are different on each one, how do I go about finding a section modulus that accommodates both? Here's how I do it. You're okay with this, hopefully. Here's what I do. I take and run a double set of data. Okay? I run one with 2 to 4, and I run one with greater than or equal to 5. So, S required is equal to 5,600 times 12 inches per foot divided by the stress in the table for each of the areas. So let's go to the table and see if we can get the right number. Okay, I'm on table on page 194. Okay, what I want you to do, I want you to look at the top cell, cell 1, 2 to 4, that's here. Put your finger on number 1 grade. Why? Because that's what the problem told us to use. Number 1, go across until you hit FB. Very first column, I think you're going to read 1,000. So if that member was 2 to 4 inches wide, the allowable bending stress would be 1,000. Put it right there. Now, if it's 2 to 4, it's 1,000. How about if it's 5 or greater? Okay, go to cell 2. Y2, it's a beam, and it's fatter than 4. Okay? Put your finger on number 1 grade, go over to that first column, and I think you're going to hit 1350. 1350 goes here. Do the math. I think you got the section modulus required for each of the two. So I'm going to put 5,600 times 12 divided by 1,000. And I get 67.2 inches cubed. That goes right here. So that's the first column you're going to fill. S required. 5,600 times 12 divided by 1350. 49 and a bunch of sevens. Two to 4, greater or equal to 5. Okay, that's the first one. Now, that allows me to go to the second one. So I'm going to put a little 1 on top of this. It's the first column you fill. The second column I fill is this one. I'm going to pick some possible choices. How do I do that? Go to page 676, 677 of your text. So 676, 677. Okay, if you're there, hopefully close to there, I will be in a minute. I'm going to put my finger on section modulus S under XX. I'm going to start running down. And I'm going to pick members that have a section modulus equal to or very close to 67.2, and the inequality says it needs to be a little bit bigger. So it's got to be at least 67.2 or a little larger. So put your finger there. I'm reading a bunch of 1s, and I get down to 1321. I don't see any 2s that make sense. Okay, I could put a 2 by 14 if I wanted to. We're going to find out that probably isn't going to, no, it's not going to work. It's got a 67.2 and I'm at 43. Keep going. I'm looking for a number that's 67.2 or bigger. Oh, I got one. 3 by 14, 73.15, a 3 by 14. Okay, there's a 3, so I got 2 is a no-go, 3 is where. Let's see if a 4 works. Now, don't put another 3 down. If you got 1 3, you got all the 3s you want. Keep going. Go down to the 4. 7, 17, 30, 40. Oh, 4 by 12 at 73.83. I'm not going to put it there yet. Okay, this is 67.2 again. Okay, I'm going to show you. I do one row at a time. So I'm going to do this first, get this concept down. Then I'm going to show you how I fill in a bunch of rows when I'm at that station. Okay, let's move down. Now, if it's bigger than 5 or bigger, we're going to look for a number that's about 50. So go down to 5. There's only one 5 by 5, and it's only what, 15? That won't work. Oh, there I am, a 6 by 8. 6 by 8, 51, 56. 6 by 8 will work. How about an 8? We got an 8 that looks good. An 8 by 8 works, 70, 31. Okay, even though I did that, like I just did, there are 2 more columns that I can fill while I'm sitting at that station. This is 2 star, and this is 2 star. Okay, I can fill those 2 in. So I can fill all 3 of those 2s in at the same time. So let's go back to that 3 by 14. 3 by 14 says it has an area of 3313. We picked it by looking at a number, and the number we looked at was 7315. That's provided. So this is from the table. Provided and area come from the table. Move down to the 4 by 12. 4 by 12 has an area of 3938. And it has a section modulus of 4 by 12. Where are you at, baby? You're right there. 7383. Okay, then go 6 by 8. Where are you at? 6 by 8 is 4125. 6 by 8 is a 5156. And an 8 by 8, 5625. And it has a section modulus of 7031. Okay, we got that whipped. Now, I've got to worry about putting in numbers for the tables. Now I'm going to adjust them. And what do we say? 5.2. I think if you remember or look in your notes, it's only good for 2 to 4 inches thick. So I can put a nice big X right here. And just rewrite the number. Okay, I've got numbers I need for the 3 by 14 and the 4 by 12. So I'd like you to go to 197. I'd like you to go under the FB column. I'd like you to find the width, 3. Put your finger on 2 and 3, go down to 14. And crisscross the 2, and you get 0.9. Next, I'd like you to go over to the 4 column. I'd like you to move down till you hit 12. And when you hit 12, I think you're going to get a 1.1. Okay, now this